Hi everybody, let's go over the following questions to prepare for your long test 4. First question, find the integral 4 over x plus 2e to the x dx. So to integrate this, we will just distribute the integral to each term inside the parentheses. That means we're just going to integrate term by term. So this is the same as integrating 4 over x, and then integrate also 2e to the x with respect to x. And we can factor out the constant here. We have 4 integral of 1 over x dx plus, take out 2 integral of e to the x dx. And then we just use the formulas that we have. The integral of 1 over x is just ln x, absolute value. So it's 4, copy that constant, 4 times the integral of 1 over x, which is ln x. And plus 2, and the integral of e to the x is just e to the x. And don't forget to write the integration constant. So that means that the answer is letter A. So next question, let's evaluate the following integral. Now, if you look at this, if you examine this, you might think, oh, I'm going to use u substitution because it has a parenthesis. Now, upon examining, if you would let u be equal to x cubed plus 3, its derivative is equal to 3x squared. And the one outside is just x. So that makes it a little bit more complicated. So I would suggest instead of doing u substitution, you try to rewrite this first by distributing 9x to each term inside the parentheses and then just apply the normal integration. So let's do that. Okay, so we will have to distribute 9x to each term inside the parentheses. So we will have 9x to the 4th plus 9 times 3 is 27x dx. Now, then you can just integrate this as usual. So this one will be equal to 9. You copy 9 and then you integrate x to the 4th. The integral of x to the 4th is x to the 5th over 5 plus, copy 27, and then you integrate x, so that is x squared over 2. You write the integration constant c. So you could input this here. You could type this as is. You could write this as 9x to the 5th over 5 plus 27x squared over 2 plus c. Next question, we are to integrate the following expression. So to do this, we will just have to integrate term by term. We could distribute the integral to each term inside the parentheses. And so for the first term, we could think of 3 over x as 3 times 1 over x. So you will have 3 times 1 over x. So you take the integral of that. And then for negative e to the 2x, you can have negative, so you put dx here first. So minus 7, take out the 7, and then integrate e to the 2x dx plus the integral of e to the 0.7 dx. For this part, you can take out the 3, and so you have 3 times the integral of 1 over x, which is ln absolute value of x. And then you copy the minus 7, the negative 7, and then integrate e to the 2x. Now, since this is now not just x, so this is 2x, then we will have to use the integral of e to the u. We will use that formula. We will have to use u substitution. So this is what we're going to use. Now, to do that, so we know that the integral of e to the u is just e to the u. So we will let u be equal to 2x. So let's integrate e to the 2x here, dx. So we will have to let u be equal to 2x, and then your du is equal to 2 dx. Now we will write this expression just in terms of u. Now the 2x here will be replaced by u, so we'll have e to the u. But the dx here will be replaced by du over 2. So it will be replaced by du over 2. Then this one here, you can just factor out the 1/2 here. So you have 1/2 integral of e to the u du. And that is equal to 1/2 e to the u. And what is u? U is just 2x. So this is 1/2 e to the 2x. And that is the integral for e to the 2x. So for this part here, you just copy this. So you have 1/2 e to the 2x plus, now we integrate this. Now be careful. Although you have e to the something here, notice that there's no variable beside 0.7. So this is treated as a constant. So this is just a constant because there's no variable. And what's the integral of a constant? The integral of a constant is just constant times the variable x. So this is just e to the 0.7x. And don't forget to write plus c. So you can input your answer like this. So next, let's find the indefinite integral of the following expression. So if you look at this, it looks very intimidating because there's a lot of radical expressions. But the technique, if you're given something like this, is to simplify it and write it in exponential form. So now remember, if you have the nth root of x to the m, you can write this in exponential form as x to the m, the power here, that's the numerator, divided by the index, divided by n. So in other words, the square root of x is just x to the 1/2. And the cube root of x can just be written as x to the 1/3. So going back to the problem here, you will have to write this in exponential form. So you will have x to the 1/2 plus 4 divided by x to the 1/3 dx. Now, simplify this further using loss of exponents. So remember, if you are dividing x to the n divided by x to the m, this could be written as x to the n minus m. Just subtract the exponents. So you subtract the exponents here. So that means you can divide each term in the numerator by x to the 1/3. So you will have x to the 1/2, x to the 1/2 over x to the 1/3. And then here, you have 4 over x to the 1/3 dx. Then you apply that loss of exponents. You will have x to the 1/2 minus 1/3. 1/2 minus 1/3. Now 1/2 minus 1/3 is just equal to 1/6. So you will have 1/6. So over 1/6 raised to 1/6 plus, now here, remember, if you have 1 over x to the n, this is the same as x to the negative n. So let's bring this expression up. So you will have 4x to the negative 1/3 dx. Then you can integrate this using the power rule. So this is equal to the integral of x to the 1/6 will just be x to the 1/6 plus 1 is 7 over 6 divided by 7 over 6 plus you have you copy 4. X to the negative 1/3 plus 1 is positive 2/3. Positive 2/3 divided by 2/3 plus C. You can input your answer like that, or you can simplify it a little bit further. You can do 6x to the 7/6. You can write it in exponential exponents, or you can write it using radical expression. So that would be 6th root of x to the 7th over 7 plus, you have 3 times 4 is 12, cube root of x squared all over 2 plus C. But as I've mentioned, you can stop here and input the answer like this. MyMathLab would still accept that. Next, let's evaluate the integral 11 to the x. So to evaluate this, let us recall that the integral of a to the x, or a to the u, in general, a to the u du, is just equal to 1 over ln a, ln of the base here, times a to the u plus c. So in other words, the integral here is just equal to 1 over ln a, our a is 11, ln 11, times a to the u, 11 to the x, plus c. Next problem, find the cost function if the marginal cost function is given by c prime of x, x to the 1/3 plus 9, and 64 unit cost $864. Now, since we are given the marginal cost function and we are to find the cost function, therefore, we would need to integrate the marginal cost. Marginal cost is the derivative. And so to get the function back, that means you get the antiderivative. So that means you just integrate this function here and use the given conditions here, initial conditions. So let's go ahead and do that. We will have to get c of x by integrating c prime of x with respect to x. So we have x to the 1/3 plus 9 dx. And what's the integral? That is x to the 4/3 over 4/3 plus 9x. And then plus c. So this is your c of x. Now we would need to compute for the c. We need to compute for c here using the given initial condition here. So you were given that 64 units, so that means x is 64. Cost, so c is equal to 864. So you have 864 here if x is equal to 64. So you have 64 to the 4/3 divided by 4/3 plus 9 times 64 plus c. Now go ahead and plug this into your calculator. All right, and then you simplify this. Okay, so simplify this. You have, so plugging in this into your calculator and simplify this, you have 768,864. So this is the value, when you plug this into your calculator, this is the value you get, plus c. Then you transpose this to the other side of the equation, you'll be able to find the value for c. C is 864 minus 768, that is equal to 96. So we have c equal to 96. In other words, we will have to write our c of x, the final answer, as x to the 4/3. Now you can write the denominator here as 3 over 4. Okay, because it's divided by 4/3, plus 9x plus the constant, which is 96. And this is the exact answer. So in the next problem, we are given the approximate rate of change in the number of design patent applications received in recent years. T here represents the number of years since 2000, and P represents the number of design patents in thousands. Now, in 2016, the number of applications for a design patent was 42,571. So, here we are to find the function that gives the total number in thousands of design patent applications received in any time, at any time, T. And from the result A, we would use that to predict the number of design patent applications in 2030. So to solve this, since we're given the derivative and we want to find the function, the number of patents, or the function that gives us the total number of design patent applications, so that means we're going to solve for P of T. So P of T can be solved by integrating P prime of T dt. So we are given the P prime of T. So this is just the integral of, maybe I'll write here, the integral of 0.01023 T plus 2.13 dt. Then integrate this. So you have 0.01023 t squared over 2 plus 2.13 t plus c. So you just integrate each term. Now, the next step is to solve for c here. We want to solve for that constant of integration. To solve that, we are going to use the initial condition here. So now we have to be careful at this point. It says here in 2016, so that is not our t, because it says here in the function, t represents the number of years since 2000. So when you say 2016, that implies that t is equal to 16. And also P represents the number of design patents in thousands. So if this is 42,571, then in thousands, that means 42.571 thousandths. So again, these two are equivalent. So this is what we're going to use. And this for T, that's also what we're going to use. So for P, we're going to use 42.571. So we have 42.571. That's your P. And then you plug in 16 to T. So 0.01023 16 squared over 2 plus 2.13 16 times 16 plus c. Then let's plug this into our calculator. So if I'm plugging this in our calculator, the value I got here is 35.38944 plus c. And then you have 42.571. Do not approximate at this point. You only approximate in your final answer. So now after this, we can solve for c by transposing this to the other side. That means you subtract both. So c is just equal to 42.571 minus 35.38944. And let's plug this into our calculator. And this is what I got. I got 7.18156. Then, now let's look at the question here. So it says here, okay, you type the exact answer. Okay, so that means we're going to use the exact expression here to get the expression for our P of t. And so our P of t will be this, and then we will use for the value of c as this number here. Now, for P of t, I will go ahead and simplify this, plug this into the calculator. The coefficient for t squared will then be 0.00515. T squared plus 2.13 t. And then for c, I'll use that value, 7.18156. So this is what you would input as your answer for part A. Now for part B, we are to use the result, the P of t here, to find the number, or to estimate or to predict the number of design patent applications in 2030. So what does that mean? We want to know P of t when t is 30. So in 2030, t is equal to 30. So let's just go ahead and plug in 30 to t. So in your t, you will have to replace that by 30. So 0.005, oops, just 2 zeros. 0.005115, 30 squared plus 2.13 times 30 plus 7.18156. Now plug this into your calculator. So upon evaluating this is what I got, 755.68556. It's 506. All right, now let's go back here, use the function, and then round this off to the nearest whole number as needed. So what would be the answer? And of course, you remember that P represents the number of design patents in thousands. So this means 75.68506 thousands. And what is that? That is 75685.06. And round this off to the nearest whole number. This is just equal to 75,685. So 75,685. Next number. We are to solve the following integral using substitution method. We are going to identify our u and what the du is. Now, upon examining this, if you recall, if you look at the discussions in your module, the natural choice for u is the expression inside a parenthesis, the one that is being raised to a certain power. So in this case, our u is equal to 9x cubed minus 7. So if that's your u, the du, the differential derivative here, is just equal to 9 times 3, which is 27, x squared, and the derivative of 7 is 0. And then you put the dx there. Okay, so this is the answer. That's the derivative, or the differential. So another problem, we are given here an integral, and this could be solved using substitution. You are to choose a function u that may be used to solve the problem and then find the differential du. So if you have a square root function, your u will be the radicand, the one inside the square root. So in this case, the u is equal to 4 minus x. And so your du is just the derivative of that, which is negative dx. So it's negative 1. The derivative of x is negative 1. All right, for number 10, if you have a rational function, you might try your u as the denominator and then find the differential. And then if you have something like this, you will have the power of e as your u because your formula is e to the u. So you might want to use that. So if you have a rational function, you won't want to see if the integral of 1 over u will work. So that formula is what you're trying to use if you have a rational function. So we'll not do 10 and 11. I want you to do that yourselves. Let's go ahead and do number 12. Here, we're going to solve the definite integral using u substitution. As I've said, if you have a square root function, the natural choice for u is the integrand, the one inside the square root function. So u is equal to 6z squared minus 6. And so du is equal to 12z. 12z dz. Derivative of 6 is just 0. Then, if you look at this, you want to express this in terms of u. So this z dz here is just this expression. So we can isolate that by dividing both sides of this by 12. So therefore, you have du over 12, which is equal to z dz. So therefore, the integral here is just equal to that z dz there will be replaced by du over 12. And this is the square root of u. The radicand is u. So you are going to integrate the square root of u. Now, to integrate the square root of u, you write that as u to the 1/2. Now, the 1 over 12 here may be taken outside of the integral. And so, you're just going to integrate u to the 1/2. So, copy 1 over 12. The integral of u to the 1/2 is u to the 3/2. You add 1 to the exponent over 3/2 plus c. Then, you simplify this. You know, if you divide a fraction and the denominator is also a fraction, you get the reciprocal of the denominator and proceed to multiplication. So therefore, you will have 1 over 12 times 2/3. Our u is 6z squared minus 6 to the 3/2 plus c. Okay, then that could be simplified. So now you have 6 times 3, which is 18. So you could write the answer as 1 over 18, 6z squared minus 6 to the 3/2 plus c. So let's have this integral here. If you were given this expression here, where you would see some expression e to some exponent, you would then suspect that the power here is your u. So you would do u to be equal to 9x squared plus 18x. That's your u. So the differential du is just 18x plus 18 dx. Now, if you look at this again, you see x plus 1 dx. Now, also, you can factor out that 18. So you have 18 times x plus 1 dx. That's your du. So you have an expression here for x plus 1 dx. Then you just divide both sides by 18 to cancel the 18 here. So therefore, you have x plus 1 dx. So that expression x plus 1 dx will just be replaced by du over 18. So you can rewrite your integral as e, and this is your u, e to the u. Now the dx times x plus 1 dx is just du over 18. Now to integrate this, you can take out that 1 over 18 outside of the integral. And then you just have to integrate e to the u. And the integral of e to the u is just e to the u. But what is u? Your u is 9x squared plus 18x. So you have 1 over 18 e to the 9x squared plus 18x. Then don't forget to write the integration constant. That's the integral. So for number 14, it's the same thing here. See, you have e to the expression here. So even this looks very intimidating. But upon inspection, if you see e to some power, the power of e, you start from there, will be your u. So your u will be 10 square root of x, square root of r. And then you proceed from there and you perform u substitution. I will not do that. I'll leave that to you as your exercise. Now, number 15, you have here a fraction. Okay, so if you have a fraction, you would use the denominator as your u. So your u will be 3y to the 6 plus 4. And then you find your du, derivative for that. And then you integrate by u substitution. So your goal here is to be able to use the integral or to reduce it into the form 1 over u du. And the integral for that is ln. So I will not do that as well. I'll leave that as your exercise. Next, I'll do number 16. So for number 16, I see some expression here and then raised to some power. If I see something like that, then I'll suspect that the base will be my u. That's the natural choice for u. So you will begin by letting u be equal to the base here, the expression inside this parenthesis here. 1 plus 3 ln x. That's your u. So du is equal to, the derivative of 1 is 0. The derivative of 3 ln x is 3 times 1 over x dx. Then you go back here and see if you could write this expression here strictly in terms of u. Now you see dx over x, and you could see that from here, the dx over x. You just have to remove the 3 here. You can obtain that by dividing both sides by 3 or multiplying both sides by one third. So you will have du over 3 equal to dx over x, dx. And so therefore the integral here could be written as u to the 9th, and then the dx over x is replaced by du over 3. Then you can factor out that 1/3. So 1/3 u to the 9th du. Then you integrate it now. So 1/3, and the integral of u to the 9th is u to the 10th over 10 plus c. And don't forget to write this back in terms of the original variable, which is in terms of x. So you will have 1 plus 3 ln x, that's your u, to the 10th power, divided by 3 times 10 is 30 plus c. So in the next question here, you are given the marginal revenue, and this is in thousands of dollars, from the sale of X handheld gaming devices, and it's given by this function here. You're to find the total revenue function given this initial condition, and also determine how many devices must be sold for a revenue of at least $43,000. So to do this, we follow the same principle we did in the exercise we did a few questions ago. To do that, we are going to find r of x from r prime of x, and that is just integrating r prime of x. So we will integrate 4x x squared plus 26,000 negative 2/3 dx. So here we will have to use integration by substitution. We will let u be equal to x squared plus 26,000, and then du from here is just 2x dx. And then notice that here you have 4x and here you only have 2x dx. So you might want to get 4x from here, and you can attain that by multiplying both sides by 2. So notice that if I have 2 du, so if you multiply this by 2 and you multiply by 2 here as well, so I will have 4x dx. So the 4x dx here will be replaced by 2 du, and this will be replaced by u to the negative 2/3. So you will have u to the negative 2/3 2 du times 2 du. So you would take out the 2 and just integrate u to the negative 2/3. U to the negative 2/3 will be u to the negative 2/3 plus 1 is 1/3. All over 1/3 plus c. So that's your revenue function. So r of x, now write this in terms of x, is equal to this. You can get the reciprocal of 1/3, then you multiply that to 2, so you have 6, and then u is x squared plus 26,000 to the 1/3 plus c. Now the next step is to compute for the c, the constant c, and to do that we're going to use the initial condition here. So in the initial condition given, it's 115 devices, meaning x is equal to 115. Now this is the revenue. The revenue for that will be 33,863. Now be careful. It says here that the marginal revenue is in thousands of dollars. So this 33,863 is equivalent to 33.863. So here, that's 33.863 thousands. So now that would be your R. That's your R. So from the equation here, you're going to plug in this value for your R. So you will have 33.863 is equal to 6 times, and then for your x, it will be 115. 115 squared plus 26,000 raised to 1/3 plus c. So let's go ahead and plug this into our calculator. So went ahead and simplify c, computed for c by, so I computed this value and subtract that from 33.863. And what I got is 170.002301. So I'll simplify that, I'll have 170. So c is negative 170. So negative 170. That's a value you get by subtracting. So your c, you subtract this from this, and that will be your c. So c is negative 170. So from there, r of x is equal to 6x squared plus 26,000 to the 1/3 minus 170. So that's the revenue function. Next question is, how many devices must be sold for a revenue of at least 43,000? So that means that this revenue here, 43,000, is your R of x. You want to compute for that x. So to do that, you just need to replace this R of x here by 43,000. But since that is already in thousands of dollars, you're going to use just 43. So 43 is equal to 6 times x squared plus 26,000 raised to 1/3 minus 170. And then you simplify this. Okay. So 43 plus 170, you move this to the other side of the equation, is 213. 213. 6 times x squared plus 26,000 to the 1/3. Then you divide both sides by 6. Okay. And then, so you have that. Now you want to remove the 1/3 here. So after you cancel that 6, you have this expression here. Then you're going to raise this to 3. I'll raise both sides to 3. So you will have that quadratic expression. Okay. So let me simplify this using a calculator. All right, and this is what I got. 44738.875. And that is just equal to x squared plus 26,000. So now you move that 26,000 to the other side of the equation. So you would get x squared. X squared is equal to 44,000 minus 26,000. And that is equal to 18,738.875. Then you take the square root. So you take the square root to get x. The answer is, so that's the square root of 18,738.875, and this is equal to 136.89. You would have to go back and see what they are looking for. It says here, type a whole number. Type a whole number. So you will have to round this off to the nearest whole number. So 137 is the answer. Approximate the area under the graph and above the x-axis with rectangles, and use the following methods with n is equal to 4, and this is a given function, from x equals -2 to 2. So for this example, I will just show you how to do left or right. I'll test you on left or right endpoints. So I'll just do letter A and B. Okay, so let's go proceed and do that. So first, I would suggest when you do this, you will have to first draw. So this is how you can easily solve this. You draw a number line and plot -2 up to 2 here. Now you have n equal to 4, so that means you divide this into 4 parts. You divide that into 4 parts. So you have 1, 2, 3, 4. You'll have 4 rectangles. Then what you would do is you would get the distance from -2 to 2. So it's 2 minus -2. And then you divide that by 4. So this is equal to 1. So you have 4 over 4, which is 1. Oh, that means this is just equal to -2. This is -1, 0, 1, and 2. So those are the endpoints. So this will be your left endpoints. Those are your left endpoints. So you have x1, x2, x3, x4, x5. So from 1 to 4 are your left endpoints. So those are the endpoints that you're going to use. Those are the points you're going to use for letter A. So to approximate the area, this is just equal to the sum of f of x sub i's delta x. This is your delta x, the length of your rectangle, the length of the rectangle. And I starts from 1 to the number of n. In this case, n is equal to 4. And your f of x sub i's here is actually the value of the function. This is your function, right? So you're going to evaluate your function, f of x equal to -x squared plus 12. Evaluate that at these points. So what I would suggest is you go ahead and evaluate the function first at -2, then evaluate it at -1, at 0, at 1, and then a 2, because you would use that, right? These are the lengths of your rectangles. Those are the lengths of your rectangles. So you will plug this in here. So you have negative 2 squared. So there's a negative sign here. That's negative of negative 2 squared plus 12. So that's 4. Negative 4 plus 12 is 8. And then negative of negative 1 squared plus 12 is 11. And then 0 squared plus 12 is 12. And then 1 squared minus negative of 1 squared plus 12 is equal to 11. And negative of 2 squared plus 12 is equal to 8. So these are your function values. So for the left endpoint, so this is left endpoint. As I've said, you're going to use the values here from negative. So these are your endpoints. So for your f of x, for the length of the rectangle, are the values here. So it will be 8 times 1, because delta x is just 1, plus, or in other words, you could also just add everything. So the simplest is you add them. So 8 plus 11 plus 12 plus 11. You stop here because you stop at 1, right? You stop at 1 at the left endpoint. And then times delta x, which is just 1. And that would be the approximated area. Okay, so go ahead and add that. So on your calculator, you would have this, and the answer is 42. Now for the right endpoint, these are the value, these are the points, these are the right endpoints. So you are going to start at negative 1. So this would be for the right endpoints. I'll put R, right endpoints. So you start at negative 1 and you end at 2. So right endpoints. So area is approximately equal to, again, the summation, and then the x sub i's here are the right endpoints, and I starts from 1 to 4. Those are the right endpoints, f delta x. So as I've said, you can just sum up all the values here of the functions. So you do 11 plus 12 plus 11 plus 8. And then times delta x, which is just 1. Our delta x is 1. And we plug this into our calculator, we get the same number, which is 42. Right, for the next number, you are to find the definite integral f of x, start from 0 to 19 for each graph of f of x. Now, this problem here, you have to know that whenever you see some expression here, the definite integral, that is just the area of the curve, area of the region under the curve from 0 to 19. Say for instance here, to find area, all you need to do is just use geometry. So we want the integral of f of x dx from 0 to 19. So that means we want to find the area from 0 to 19. So this is actually 19, right? The figure, this was 21. This was 21. And you can count. Okay, so since we don't know what that f of x is, but we know that the definition of this is just the area, and from the figure, it looks like it is a triangle. So that means you're just going to find the area of that triangle. So you have 1/2, the area of the triangle is 1/2 base times height. So 1/2 base times height. The base is just 19. So 1/2, our base is 19. That's the base here. And then the height is this one here. That's the height. Okay, so the height will be 1, 2, 3, 4, 5, 6, 7, 8, 9. That looks like it's 9.5 times 9.5. See, and then you just multiply that. That will be the area. And upon simplifying this, I got 990.25. So that's the area of the region under the function f of x from 0 to 19. And the same principle applies. You use the same principle to solve for this one. So this is a triangle. Therefore, to find the area here, you just have to use the area of the triangle. So this is your base, 19, and that would be your height. So you just have to count the height. And then use the formula for the area of a triangle. So this next question is on evaluating definite integral. Now, upon inspection, this expression here would require integration by substitution to solve. So let's go ahead and do that. So this expression here will be our u. So u is equal to 7y to the 9th minus 9. And then du is equal to 9 times 7, 63, y to the 8th dy. Now, notice that you have y to the 8th here as well. And so therefore, you can write this as u, your u is the expression here. So that means u cubed, and the y to the 8th dy, you can isolate that, can be replaced now by du over 63. So you will have du over 63. Now, for the limits of integration, this is the value for y. So that is in terms of y. So y from -1 to 0. So since we did u substitution, we should also change the limits of integration. So you make sure to change the limits of integration as well. So now here, for your u, so using this, your u is 7y to the 9th minus 9. So you change the limits of integration by evaluating your y at these values. So we can do when y is equal to -1, your u is equal to 7 -1 to the 9th minus 9. And -1 to the 9th, that's odd. So that means that's equal to -1 times 7 is -7. So that's equal to -16. So u in this case is -16. So when u is when y is -1, u is -16. So this becomes -16. Now let's look at when y is equal to 0. What is u? U is 7y to the 9th, so 0 to the 9th minus 9. So 0 minus 9 is equal to -9. So that's -9. Okay, so from -16 to -9. Then you can now integrate this. You can take out that 1 over 63 and then just integrate u cubed with respect to u from -16 to -9. And this is equal to 1 over 63 u to the 4th over 4. Evaluate from -16 to -9. Then go ahead and simplify this. So we have 63 times 4. So that's 252, 1 over 252. And then you have -9 to the 4th minus negative 16 to the 4th. Okay, and then I'll plug this into my calculator. So the exact answer here is negative 8425 over 36, or in decimal, it's negative 234.027. Now let's see, you are asked to type an exact answer. So if you're asked to type an exact answer, this is the answer you need to type in. So next, I chose to do this number here, evaluate the definite integral. So as I've said, if you have a rational expression, there's a denominator, your goal is to let the whole denominator as your u. So that would be your, as a first step. And then you go and check, see, would that really be possible? See, in this case, the whole denominator is actually being raised to 2. So it's also quite complex. So that will just complicate the expression if you're going to make that as your u. So then you try a different approach. Maybe just let this as your u. So u is just 4 plus 9e to the 9t. e to the 9t. So this is a good choice because you have e to the 9t in the numerator. Because you know that if you differentiate u, the derivative of 4 is 0, and the derivative of e to the 9t is just e to the 9t times the derivative of 9t, which is 9 dt. So you got 9 e to the 9t, which is this expression dt. So to get the expression for e to the 9t dt, you can just divide both sides by 9. So you have du over 9 is equal to e to the 9t dt. And so the expression here becomes, this will be replaced by d over 9. So you can take out that 9. And so you have du all over. Now the denominator, or you can do 1, and then you put the du here. Now the denominator will just be u squared. Now also make sure to change the limits of integration. So we're not done yet. We still have to look at the limits of integration. And how do we proceed? We're going to evaluate our u at these values of t. So when t is equal to 0, you compute for u. u is equal to 4 plus 9 e to the 9 times 0. 9 times 0 is 0. E to the 0 is 1. So that is just 4 plus e. And then when t is equal to 3, you will have u 4 plus e to the 9 times 3. So this is just 4 plus e to the 27. All right, so that would be your u. So this is your new limits of integration. So just be patient. It looks a little bit more complicated, but it would just help you. So plus e to the 27. Now you can integrate this by writing this in exponential form. So you have 1 over 9. Write 1 over u squared as u to the negative 2. u to the negative 2. Your limits of integration is 4 plus e, 4 plus e to the 27 du. Now you're ready to integrate. So you have 1 over 9, and the integral of u to the negative 2 is u to the negative 1. So you add 1 to negative 2, that's negative 1, divided by negative 1. Then you evaluate it from 4 plus e to the 27. So you have negative 1/9, 1 over because u to the negative 1 is 1 over u. 1 over 4 plus e to the 27 minus 1 over 4 plus a. This is the exact answer. Now, let's see what was required of you. Yes, you write the answer in exact, okay, in exact form. So it is in terms of e. So this is the expression that you need to type in. So for the next question, we are to use the definite integral to find the area between the x-axis and f of x over the indicated interval. Now, to do this, we have to make sure to check if the graph crosses the x-axis on the given interval. You can do this by looking at the graph of the function or just by examining it. So how do we do that? So you can actually plug in this expression here and see if the function values changes from negative to positive. Okay, so from negative to positive, or you can just see, okay, is there any x that makes it 0, and is that 0? Because when you say f of x equal to 0, the graph is intersecting the x-axis. So you want to see if the graph would cross the x-axis. So that's the intersection at the x-axis. And you want to know if the intersection at the x-axis lies within the interval here. And so to do that, you will have to let your f of x be equal to 0, and you solve for x. Now, so 2x cubed equal to 0 when x is equal to 0. So if I divide both sides by 2, I have 0x cubed, and this can only be 0 when x is 0. And 0 is actually on the closed interval. So that is on the closed interval, negative 5 and 5. So because of that, when we integrate this, I would say to make it a lot easier, after you get the intersection at the x-axis, you just have to split the interval. So you're going to split this negative 5, 5 to negative 5, 0, and then 0, 5. You include 0. So when you set up the integral for the area, you will do from negative 5 to 0, 2x cubed dx, plus from 0 to 5, 2x cubed dx. Now, one of these will give the negative area. You don't know which one. Or if you know, good for you. If you don't know, just take the absolute value of each and you'll be fine. Just take the absolute value of each, you get the same answer. All right, so you get the area here, you integrate it, negative, the integral will be, the integral of 2x cubed is x to the 4th over 4 times 2. So 2x to the 4th over 4. Then evaluate that from negative 5 to 0. Take the absolute value for the answer, especially if it's negative. And then the same thing here. It is 2x to the 4th over 4. Now evaluate that from 0 to 5. So that cancels. So that's only 2. So now you have 0 to the 4th minus, so you put the 1/2 here, 1/2, 0, so there's 1/2, and then 0 to the 4th, 0 to the 4th minus negative 5 to the 4th, and then plus 1/2, 5 to the 4th minus 0 to the 4th. So you have 1/2. Now negative of, what is negative 5 to the 4th? So let me evaluate that on my calculator. That is 625. So see, you will get negative 625 here, negative 625. But you would take the absolute value for the answer. And then here, you will have 1/2. 5 to the 4th is 625. Adding this 2, you get 625. That's the area. If you're not careful and you don't put that absolute value, you immediately evaluate the area from -5 to 5, you'll get the 0, which is actually wrong, because you get a 0 because you get the negative value here, and that would be subtracted from the positive value here. Since both of them are have the same numerical values, then the answer is 0, which is actually wrong. Okay, so just to avoid any mistake, you just take the absolute value of each term, and then that's the answer. For this next problem, we are to find the area of the shaded region. So I'll go ahead and set up the area of the shaded region, and I leave it up to you to evaluate it. So you are to find the total area of the shaded region. So that means you get the area of the region here and the area of the region. So area, the total area is A1 plus A2. And then let's set up the integral for both A1 and A2. A1 will be the integral, the area under this curve here, 25 minus x squared. So to help you, you can actually create a rectangle. So you would have top minus bottom. So this top here is 25 minus x squared, and the bottom part is actually y equals 0. So that's y equals 0, so that means it's just 0. So therefore, you have 25 minus x squared minus 0. I would say area, for the area, remember that area is y top minus y bottom. Okay, and you do that the same for a sub 1 and a sub 2. So here, the y function at the top is 25 minus x squared. And the y function at the bottom of the strip, is the x-axis, or the line y equal to 0. So minus 0, dx. And x runs from 0 up to this point here, which is 5. That's for this area 1. Now for area 2, you do the same thing. You create a rectangle here. Then you would say y at the top. What's the function at the top? That was just the x-axis. So that's the 0. The 0 minus, what's the function at the bottom? This function here is the same as this curve here, which is the parabola. So minus 25 minus x squared dx. Now, where your x is from? X is from 5, and it goes through 6. So this is the area of the integral that would compute for the area of the total area of the region. Then you go ahead and integrate this. So I'll just integrate it. So you have 25x for this, and minus x cubed over 3. Evaluate that from 0 to 5. Here, you may rewrite this as x squared minus 25. So you will have x cubed over 3 minus 25x. Evaluate that from 5 to 6. And so you have 25 times 5 minus 5 cubed over 3 minus 0. Minus, you will have 6 cubed over 3 minus 25 times 6 minus for 5 cube here. 5 cube over 3, you plug in at 25, minus 25 times 5. 25 times 5. 25 times 5. I don't have space. So let me just erase that part so I have more space. So I'll have minus, and then evaluate this at 6. So 6 cubed over 3 minus 25 times 6 minus 5 cubed over 3 minus 25 times 5. There we go. And then you plug that into your calculator to find the answer. So upon plugging this into my calculator and simplifying it, I got 78. So 78 is the total area of that shaded region.